Tata Elxsi presents Talk to Tata Elxsi, EV HILS Validation. Answering your frequently asked questions on EV validation, Tata Elxsi's validation framework and services for electric vehicles. What are the various services offered by Tata Elxsi for electric vehicle validation?
Tata Elxsi supports its various OEMs and supply customers in various phases of electric vehicle validation. As a trusted partner, bringing in cost, time and effort savings. We support our customers mainly in 10 activities. 1. Test system design, development and commissioning. 2. Test specification development. 3. Test execution, bug reporting. 4. Plan model development. 5. Test automation framework development. 6. Benchmarking of various competitive devices under test. 7. Retrofitting of various normal vehicles to electric vehicles. 8. Resource augmentation business model. 9. Vehicle testing and vehicle test data collection. And finally, providing the in-house validation as a service HILS test suite, which we call eMobility HILS for EV validation.
What are the various levels of validation supported by Tata Elxsi? And what are the test setups used?
In the aforementioned, we mainly cover software qualification testing, system integration testing, and system qualification testing, complying to both ASPICE and functional safety. We use test benches, HILS framework, lab car, and even real vehicle testing to achieve this.
What are the different HILS simulators with which Tata Elxsi has worked?
Tata Elxsi has extensive experience in working with the DSpace, NI, Vector VT, Opel RT, HILS, and even from modeling side, Tata Elxsi has a talented group of engineers certified in MATLAB and LabVIEW.
Can you explain your service offering on HILS system design?
We start with analyzing the detailed system requirements, I/O specifications, vehicle architecture diagram to come up with a preliminary set of I/O modules, real-time processor, power supply, etc. We have very close communication with various HILS vendors, which enables us to have close interaction and arrive at the most feasible and optimum HILS design. Tata Elxsi can take up the complete responsibility of integrating various HILS devices, third-party devices, and perform HILS prove-out. This will be then handed over to the customer after showing the relevant prove-out criteria.
Do you have a dedicated test infrastructure for EV validation?
Yes, the EV test suite, which I mentioned before, is invested by Tata Elxsi, which enables component, system and vehicle level validation of EV or HEV systems. It is a ready-to-use test system which brings in the cost and time savings to the end customers due to the testing or validation as a service business model. This facility is located in the India office of Tata Elxsi, where cutting-edge HILS solutions based on DSpace, NI, Vector VT, etc. are made available to customers. Automotive-grade high slew rate power supplies, DC electronic loads, fault insertion units, cell simulators, FPGA simulators, charging station emulators, dynamometers, thermal chamber, chiller, etc. are made available for enabling closed-loop real-time validation of EV systems at both signal level and power level.
What do you mean by TARS or VAS?
This is a business model where customer only need to pay a usage fees for using the test bench for a predefined period of time. One need not wait for the HILS devices to arrive, and also the customer need not invest in costly HILS required for the EV validation. Customers can give us the device under test and the supporting artifacts, and we take up the complete ownership of end-to-end validation and provide back the test results to the customer along with supporting log files. Attractive offshore engineering rates is another key reason for the cost efficiency of the proposed EV test suite.
Using the EV validation services, what systems or components can be tested? What are the various tests that can be performed?
The EV test suite currently supports the testing of cells, battery, cell monitoring controller, battery management system, motor controller, inverter, charger, vehicle supervisory controller, hybrid control unit, power distribution unit, junction boxes, e-axles, EV powertrain, transmission and drivetrain units, etc. Major types of testing covered are functional testing, diagnostic testing, efficiency, performance, long run, drive scenarios or cycle-based testers, standards testing, loading, network management, and even homologation testers.
How would it be beneficial to suppliers and OEMs working in electrification?
Tier 1s and OEMs can use the proposed EV test suite to test and benchmark their EV systems. Flexible business models like validation as a service, test farm, turnkey solutions, time and material mode of engagement, developing new hills or even upgrading an existing hills at on-site are available. Up to 70% cost savings in CapEx and engineering is achieved when using the proposed validation as a service business model.
Can this setup be installed, recreated at the customer's end for project-specific purposes?
We also support our customers in developing new hills or even upgrading an existing hills at customer site. We understand the technical requirements through close interaction with the customer, speak with tool vendors, design the hills, commission the hills, and provide prove-out training and hands-on to the customer. We also have resource augmentation mode where our engineers support end customer in testing of EV systems at customer site.
What level of process compliance do you guarantee in your testing?
We adhere to ASPICE Level 3 and ISO 26262, and we offer validation services for SWE6, SIS4 and SIS5.
What will be inputs for testing services and what will be your deliverable to us?
We need the device under test specifications like system requirements, pinout, ratings, diagnostic specification, communication database files, schematics, and also the device under test along with harness and the supporting connectors. Our deliverables back to customer will be the test cases, test reports, log files, plan models, and even the real-time test automation framework.